Given our current growth, I am certain that you can help us reach 1,000 subscribers by liking, commenting, and sharing this video, and of course, by subscribing to the channel. Thank you. Welcome to the Introduction. Introduction to the world. You exist. You exist as a somebody. A somebody whose entire world necessitated other somebodies for years. A somebody who was fed before knowing what food was, or how to gain it, or that it was needed. A somebody who, despite not knowing it was food that was needed, cried in pain when something was wrong, which upon being satiated, it went away. A somebody who over time realized that the pain would stop when you cried and people fed you. A somebody who over time realized that if they didn't feed you, you could keep on crying until they did. A somebody whose ability to interact with the world to get what you wanted gets retained and referred back to often, strengthening that connection to others and reality in general. A somebody who had to learn how to move their limbs and later walk and talk, and all before having the ability to question what any of that means. A somebody that starts to learn about what they are seeing and hearing and touching and smelling and tasting, all before they can describe those perceptions. A somebody that starts asking questions and retaining the answers to those questions, all before they can think about what any of it means, and before they can introspect that it is a somebody doing these things. A somebody that gained experiences by putting in an effort in some way to some degree and got out some benefits and/or punishments. A somebody whose mental actions in the face of those experiences formed a certain view on the world and a certain view of other somebodies in that world. A somebody that one day, seemingly out of nowhere, exists as a nearly fully developed person, who can finally look back at themselves as a somebody that does stuff and knows stuff. A somebody who decides one day to study the nature of existence and become a philosopher, a scientist, and an artist of their own making. A somebody that starts to question things like, why do we call dogs dogs? Where do words like dog come from? Who decides that we should call all dogs a dog? Why that word? How do we even know all dogs are a dog? How did I come to know all this information about dogs? Matter of fact, who am I? Why am I so obsessed with dogs? What is my identity? Where do I belong in this world? Ontology. The true purpose of philosophy is that it is a science that any somebody can do. A somebody capable of abstract thinking should be able to construct a kind of list of things that exist in some form or another. As somebodies, we should all be able to form a list which goes something like this. Substances. There are things. Properties. Those things have things about them. Relations. Those things about them are similar to other things, and things interact with other things in certain ways. Facts. Things about those things are true even when we don't see them in front of us. And they do what they do because of their state of affair, both within themselves and between other things in the world. Events. The places and dates about which these things do the things that make them the things which they are. Values. Some things are worth more than other things. Minds. Things, or at least just our own somebody, appears to do things because we want to, whereas some other things don't do anything until something else, including a thing that wanted to, interacts with it. Example. A rock is a thing. A rock has hardness and colors and textures and a weird taste. A rock relates to other rocks by appearance and many other qualities. A rock relates to pain when dropped on your foot. A rock relates to food when it is used as a tool to crack open nuts. I know it can do these things because of the way it is. I know I can pick one up long before I need it, and I can use it later, and it will still work. I know this because of the state of affairs of hardness and crushing pain and fragile shells. I know I found the rock at a certain place and at a certain time, and I will use it at different places and at different times. I know a rock makes people joyful when it crushes walnuts because eating food feels good. And I know it makes people sad and angry and in pain when it crushes body parts because pain hurts. I know that joy, sadness, anger, pain, and pleasure are things somebody's experience, and they do not appear to be themselves things, nor are they properties, nor a relationship, nor a fact, nor an event, nor a value in themselves, but rather are merely ways of being conscious, of experiencing mind. They are concepts of consciousness, a thing which, it would appear, that not everything has, or not everything has to the degree to which somebodies like us do have it. Metaphysics. What does it mean, metaphysically, that we can see and touch and taste rocks? To taste is just a type of touch. So what is the difference in rock identification between sight and touch? Touch requires immediate contact with the object. It then becomes like an extension of your hand, and, in certain manners, can act as such. But it does not become a physical part of your body. It remains a rock in your hand. It does not become a singular entity called a rock hand. When the rock is no longer in our hands, we no longer sense it by touch. A medium is the way by which an interaction occurs between objects and us. The medium of the sensation of touch of a rock is with both the rock and the hand. Touch means the absence of an intervening body. It is body-to-body contact. It is something about the rock and something about our hands and us, and the way they interact that makes roughness and hardness observable units. Whereas the sensation of sight of a rock does not require us to be in immediate contact with it. And if you do press the rock to your eyes to see it, as you had pressed the rock to your hand to touch it, you lose the color and other visual percepts of the rock. It is also the case that we cannot see the rock when it is dark, but we can feel it in the dark. We can also add any other color of light to the room, which will cause the original color of the rock to change. The color of the rock cannot come from the rock itself, in the way in which the property of roughness came from touch, and therefore the property must belong to the medium between us. The medium of light, or the medium light moves through, is the way in which we perceive the rock by sight. It must be the case that something of some nature exists between us and the object of perception. Such a medium would be in immediate contact with us, such that we could be in contact with the other objects without bodily contact. Since this medium exists, it must be a kind of substance, meaning exists with properties, and this medium must have properties which allow for light and sight, as well as objects like ourselves and rocks to exist within it. The whole universe must be filled with this medium, as we can see colored light from stars, meaning that the same medium that is between us and the rock is also between us and the stars. These substances and their properties are related to other substances and their properties through similarities of perceptual units, or through relations of perceptual actions, which are measurable in perceptual units. For example, a rock is similar to other rocks, compared to trees and dogs and people, so we call it a rock. It's hard like a rock. It is made of earth materials commonly found on the ground. It doesn't grow, and it doesn't move on its own, nor does it eat, or drink, or react to painful or pleasurable stimuli. So we have identified this substance in our hand as being similar to other substances we call rocks by using properties of the substances, which we can call units. In this case, there are units of measurable sizes, like length, height, and width, as well as units of measurements of shapes, colors, weights, etc. This perceptual awareness occurred at a very early stage in your development as a somebody. The process of how you did it was not at that time introspectable, and the process which is now automatic is such that what is immediately available to you as a somebody are the objects themselves. That which is not immediate to you, but can become observable through introspection with a focused mind, is that those objects are rich with properties that you can measure and describe. Epistemology. We can decide to cut off the size limits of rocks and say that anything too big to pick up is a boulder, and therefore a rock is the same substance of a boulder, but can be picked up by a person. This means that we can create a sort of tree branching diagram, where we place rocks and boulders on one level of the branch, and can form a concept which carries both units as being similar. Let's name this parent concept Earth with a lowercase e, which we can say is the sibling to water, and whose parent is Earth with a capital E, which we will continue on and say is a sibling of the other planets like Venus, whose parent, we could say, is the Sun, whose siblings are the stars, and so on. Further units of the rock are the weight, color, material, shapes, tastes, hardness, roughness, strength of a smell, and type of smell. As such, we could find rocks that are identical in shape and color, but not of size or weight, and we could organize the rocks from smallest to largest. Or we could find rocks that are identical in weight and size, but not of color, and organize the rocks by the colors of a rainbow. In each case, we see that the unit is a perceivable aspect of the substance mentally abstracted out of the substance and held as a measuring stick for other substances, such that a rock looks nothing like a tree, as a tree is tall and cylindrical. The rock is typically flat or round but jagged and fits in a person's hand. These units, when put together, encompass the percepts that form the concept of a rock, which itself become a unit. By making rock a unit, one does not need to observe every single perceptual property of each rock in order to know that one will likely do the trick. Although there is no guarantee that the one you select will do the trick, but in such a case, you will learn something new about a certain type of rock. For example, if you want to get a rock so you can crack open some nuts, you don't need to experiment or overanalyze the properties of each rock that you see on the ground. Given enough exposure to rocks, you will automize perceiving those properties which are vital to the operation of nut cracking, and integrate them together into a higher level abstraction, conceptualized, perhaps, as a nutcracker. This new abstract concept for a certain type of tool acts as a single new unit, automizing the operation such that you spot a good nutcracker without even trying. It seemingly just pops out at you. As another example, when you are first seeing a dog, you see it, but you don't know what it is, and its name, Doggy, needs to be told to you. Later, you see one and say Doggy. The more dogs you see, the more you see they differ, and you learn the names of different dog breeds. Suddenly, when you see a dog, you don't just see a dog, you automatically see a German Shepherd. This can be said to be the purpose of forming a concept. It acts as a kind of time saver, and can be metaphorically viewed as a type of file folder. The file folder is labeled by the concept itself, and in the file folder of dog are the units that belong to dogs, like the fur types and colors, breeds, sizes, etc. The file folder needs to be capable of housing an unlimited number of elements, as it will include all the dogs you have ever known about, and will be used for any dogs you will ever know about. It also contains any dog facts that you have learned, and will be used to hold the dog facts that you learn in the future. A new unit is added to the file folder by a new perception, and also by a process of reasoning new knowledge based on earlier perceptions. This suggests that units are formed and continuously updated. Further, any facts acquired about the object remain true in the face of new facts. A furless dog does not prove dogs are furless, but rather demonstrates the usual reason that dogs have fur and what can change about that. Acquiring information which is false about a concept, however, will contradict with a true fact about that concept, and can be removed from the conceptual file folder. Facts, then, are based on the nature of the object, and they do not change over time. In the case of dogs, the fur comes from the type of animal a dog is in the evolutionary tree, and their ability to lose it is just as biologically measurable. These file folders did not always exist. Every single one of them had to be created from percepts we perceived through finding commiserable characteristics. The nature of consciousness. How we decide where to cut off our definitions for concepts, and how we decide if information belongs to a concept, is a capability of our consciousness. What we know about consciousness is that every aspect of it is conscious. We know that it is somebody's consciousness, and we know that existence has primacy over consciousness. We can know all of this because consciousness is the identification of the identities of objects by a certain kind of object, in this case us. Consciousness cannot be primary, as it must have a being which experiences something outside itself first. Before a consciousness can identify itself as a conscious agent, it has to learn about the world. It has to learn about other conscious agents and inanimate objects, and the space and time between them. Hence why it takes so long for us to develop an identity for ourselves. Identity formation is an adolescent problem. Consciousness is therefore specifically an interaction with the existing world, and is not reducible to non-consciousness. Consciousness is not your brain, for you can cease to have a consciousness while your body retains the brain and its functionality. For example, in order to do certain surgeries, a patient needs to be unconscious, and this can be achieved by anesthesia, which knocks out your consciousness, but not the neurons and their ability to function properly. The brain is functioning perfectly. The consciousness is not present. Consciousness, therefore, interacts with your brain in some physical way. The physical way in which your consciousness interacts with your brain also must allow for volition, volition being a kind of causation. Causation is a relationship between an action and the nature of the object acting, and our nature is such that we can decide when we want to act or not to act. This is done in a sense by an act of focusing, or by an act of tuning out. By focusing on proper units, we can learn, or by going out of focus, we can let whatever comes in come in, and whatever actions go out, go out. Therefore, however consciousness interacts with the brain, it does so with a volitional nature. Our ability to form concepts being tied to volition and focus means that we are capable of focusing on the wrong things, and improperly forming our concepts, which will make it harder or impossible to deal with the actual thing in reality. Therefore, we need to formulate a guide to proper thinking. It is not enough that we differentiate and integrate our percepts into concepts. We should also deduce and induce our knowledge about these concepts as to check them against reality. Induction and deduction. The holding of concepts allows us to slow down and put old relationships together to form new relationships. This focused slowing down and thinking is a kind of mathematical process. The essential characteristics of the concept are the units which we abstracted for the purpose of comparing their measurement differences. It is a moment of ignoring your base animal percepts to focus inward on the memories you formed earlier in order to create something which can be called man-made. The man-made starts with the processes of induction and deduction. An induction is the conceptualizing process, and as such, one can check the falsity of an induced concept by checking if it violates causality or nature. As the concept will be reducible to measurable percepts, a proper inductive concept will start with self-evident generalizations, and will use methods of difference and agreement to discover contextually causal connections, which integrates with all other previously learned knowledge. The fact that all concepts are man-made products of abstracted percepts and can be infinitely subcategorized and subdivided means that every induction can be removed from its proper context to appear wrong. But if the induction is correct, that "well, actually" argument will only further prove the original context as true based on its nature in that environment with those other objects, and that this new context which makes the statement appear false merely provides us information about the universe. For example, all paper burns. The nature of paper is that it is made of wood, and wood is of a nature that it is composed of elements which are flammable. And by the transitive properties of paper being wood and wood being flammable, paper is flammable. The invention of a contract paper which is non-flammable as to survive a fire will either be regular paper with a special non-paper coating that prevents the fire from touching the paper, or the paper is not wood paper, but a different material we learned how to make because of the properties of flammable paper. Deductions are therefore the natural result of inductions, which were not evidently obvious following the conclusion of the inductive conceptualization process. For example, the famous deduction, "All men are mortal. Socrates is a man, therefore Socrates is mortal." The conclusion follows from the transitive property, meaning that if our brain automatically creates a tree of knowledge, it would be clear from the path line that one can trace their finger from mortal things to man to one of the men, and vice versa. Both are equally obvious. Because of the vast number of percepts and properties and other concepts inside of all concepts, it can be easy to miss these connections. Just because an induction was true does not mean that every single relationship that exists between them and reality becomes obvious. The Socrates example is simple, but imagine it from a child's point of view. The child, long before ever losing a loved one, learns that people can die. They may understand from the context of a movie or a story, and that they truly understand exactly what it means. They also know that grandma is a person. But when they learn that grandma is dying or died, the connection might not be there, and you have to walk them through the steps, relating it to the other, previously acquired knowledge. Both methods of checking our concepts against reality reduce down to perceptual units, and therefore we are able to consider the concept in mathematical terms. Our senses detect these percepts, but they ultimately do not depend on human senses. That a rock feels rough is directly related to our touch perception. That a rock looks a certain color is related to the interactions between the rock and the medium in us. But our understanding of rocks through slowed down, focused reasoning can say, ignore roughness and coloredness, and look here at the elements that are the parents of those properties, the countable number of stuff that make them this stuff. Look how roughness and color are caused by the nature of the rock, by its quantum properties. By quantum properties, I do not mean to jump into the deep end of physics, but rather, philosophically speaking, the word quantum happens to reflect exactly what I mean. Quantum meaning the smallest amount of a physical quantity that can exist independently, the base unit that all physically measurable units reduce down to. Our perception of the quantum nature of the rock through roughness and color, despite not seeing quantum particles at all, is quite accurate because of the nature of our quantum particles as causal entities. Reasoning mathematics. To check if a particular object falls within the definition of a concept, thus allowing it to be a member of that concept, requires that they have the same units, and that those units are within a boundary that is acceptable. As such, one can formulate the conceptual common denominator as a type of mathematical limit. Conceptual common denominator limit, CCDL. The object can be said to belong to the concept as its characteristics approach the concept's characteristics. If for every unit that exists, there exists that unit in the object, such that if the difference in characteristics is less than the common denominator, then the object belongs to the concept, and the error in difference can be said to be within an objective range. This definition of the conceptual common denominator limit provides a mathematical formulation of similarity amongst entities. Each one of these concepts, which are held together with a type of mathematical precision, function as the elements of algebraic expressions. Algebra is the process of reducing and balancing concepts. In both forms of algebra, the process is composed of things with units, and the purpose of the process is to find the relationship between them, such that you can say that one is equal to the other in some form. In this manner, all conceptual generalizations are a form of algebraic expression. All inductions and deductions are a form of algebraic expression. To prove that the object is that which you claim it is, requires that you show that the object has all the essential characteristics of the class, and that those characteristics fit within an error value, which is set by the identity of the concept or object. In mathematics, the essential characteristic is quantitative numbers. The classes that the numbers can equal are simple numbers, roots, squares, and so on. The goal of algebra is that one is always looking for how many units of one type are equal to the number of the other type. And, in all cases, the large classes can be reduced down to the smaller, and the expression itself can be reduced down to the essentials. The same can be true of language and concept formation. The sphere can be algebraically reduced to its base units. This sphere has a shaft. This sphere has a head. The shaft is made of wood. The head is made of stone. The wood is a cylindrical shape. The stone is an arrow shape. The cylinder is 2/3 of a finger across and 4 feet in length. The stone is as heavy as a cow's skull full of water. These numbers and lengths and weights and materials and shapes are percepts abstracted from objects, and they are used to differentiate objects from other things, and can be reduced down to measurable values, therefore giving rise to physics and applied mathematics. These mathematical and physical values, which include that the wood and stone are made of chemical elements which can be reduced down to a countable number of protons, are provided through the medium of information exchange of energies between you and the object, but they only truly come through to you in this manner by slowing down and volitionally abstracting them and putting a name and measure to them. Thinking, then, is an effortful, volitional process of combining identities which obey a causal nature by forming a mathematical formulation of precision, of similarities and differences of units identified within the object or concept. Language, then, is foremost a process of thinking, the structure of language being similar to algebra, as the units of things which we are thinking about are being sorted out in our brains in a way which is fundamentally related. For instance, the Socrates is mortal syllogism is a logical structure which is, in one sense, mathematical. It is equating a root, men, with a square, mortality, and a number, Socrates, with a root, men, and finding that the number is equal to the square. This structure is ultimately neurological. In order to get the statement, all men are mortal, requires that the brain can hold information about men and mortality, and can put them together, or could try and imagine them as apart. The mechanisms by which we do this will shed light on why concept formation and mathematics are so similar. The mechanism itself is based on the structure of the region of the brain that encodes this information. The evolutionary formation of biological perceptual distinctions comes from the physical brain functions. How the brain generalizes knowledge. The brain then can be thought of consisting of regions where the sense organs are taking the information for processing. Each of these sense organs then comes together with their perception of the world, and they integrate together into a larger perception, and can be stored in memory somewhere in the brain. The region of the brain that integrates the spatial maps of the world that you use to navigate is the same region of the brain that integrates the non-spatial cognitive maps of the world. Percepts, concepts, mathematics, and everything else are all processed through the same physical mechanisms. For instance, the hippocampus and the entorhinal cortex. These regions allow for the formation of memory. Evidence shows that the entorhinal cortex cognitively maps out both spatial and non-spatial relationships, where the units of measurement are mapped out in an abstract representational space that is navigated from current location to the goal state. Therefore, the requirement of unit abstraction is important to concept formation, as that is the feature which is being measured. The structures in the brain are laid out in this pattern, and as such, they act as the structural backbone of information, acting as all maps, tree diagrams, algebraic expressions, etc. The concretes that exist are processed in the hippocampal region. These two integrating mechanisms are such that one region creates a general map, and the other fills that map with concrete information. For example, one region holds that one unit is one unit no matter where they are on the planet, and that you can take 4 steps to move one unit, and that moving north, then east, then south, then west, 1 unit each, will get you to stop right where you started. The other region remembers concretes, and given a map, can place them around the environment to help you navigate. This mapping structure provides a hierarchy of knowledge, which presents as a whole, proving why it is fundamentally just as easy to move up the inductive hierarchy as it is to move down the deductive hierarchy. This is possible due to the way in which this brain region physically exists. Without getting into any details, we can work out what needs to be done. 1. The brain is composed of task-specific regions. 2. The brain has a finite amount of stuff, and as such, necessarily also has a finite amount of information processing power and a finite amount of information storage capacity. 3. Therefore, each specific region has a limited amount of processing power and storage capacity. 4. An unlimited number of concepts can be formed, and an unlimited number of entries can be added to a conceptual file folder. 5. Therefore, each specific region must have the ability to generalize the task, while also allowing for particular objects or concepts. What we will find then is that the brain has some specific regions, which through their physical structure create a general pattern for integration and differentiation, and will create a means of placing specific objects in those patterns. These patterns will be right in front of our eyes, as they will be the same patterns that we use to think out loud and use to share thoughts with others. When you introspect on such things, you find that maps are a general structure that we fill with concretes. Other such regions do the equivalent of tree modeling, again, that being a general structure that we fill with concretes. The patterns of a logical argument or the patterns of an algebraic expression are other forms of general structures which get filled by concretes. All the ways in which we talk about metaphors and analogies is a product of how we encode knowledge. Since all of the stimulus we receive is processed in the same handful of brain regions, those regions will have no room to construct a new spatial coordinate system, or a new non-spatial mapping system, or a new category tree for every single relationship. There is just one region that takes in all percepts and/or concepts and lays them out into a hexagonal pattern, and to compare the common denominators to determine if this object belongs to the concept or not. You measure the distance between nodes. As such, the CCDL is the result of the representational mapping of information on the cortex. This explains why concept formation is in large part a mathematical process. The process is similar physically to mathematical graphing, with distances acting as factors in the similarity between objects and concepts, and hence why abstract notions of more just or less just can exist, or my sense of justice is near my sense of honesty. In this representational CCDL space, justice and honesty can be right next to each other. The problem with moral issues is how the concepts were induced, such that some people might view man as naturally evil, and therefore cosmic justice might mean dishonesty is closer to justice. Through this understanding of the triple integration, one could show the objective nature of morality. How consciousness uses the brain. As discussed earlier, consciousness is irreducible. In that sense, using language as established so far, one can say that consciousness is its own type of quantum unit. As such, we need to distinguish between levels and states of consciousness to be clear about our discussion around it. To clarify, one can say all living beings have consciousness. Even a single cell has a consciousness. This statement is using the quantum notion of consciousness, that any and all interactions of a living creature responding to external or internal energy changes is a form of awareness. Consciousness is just awareness of any form. We also know, however, that people have way more consciousness than the individual cells that we are made from. Because we know that the whole has more conscious power than the parts, we can quantify consciousness into mathematical, measurable units. The manner in which we are going to have to try and reduce it to its quantum base in order to measure it will require that we know what consciousness is. Whatever consciousness is, it must be capable of the following tasks. 1. It must be capable of stamping information onto the brain. 2. It must be capable of retrieving information. 3. It must be capable of moving information around the brain by the nature of retrieving and stamping. 4. It must be capable of acting in a way which is not random nor deterministic. 5. It must be capable of experiencing a difference. Consciousness, as we have seen throughout this video, is able to learn about new facts of reality, and in fact was a blank canvas when it first came into being. Shapes and quantities and textures and smells and colors, etc., were first detected, then integrated, then stored in the brain somewhere, somehow, and this information was novel. But the more you were exposed to these entities, the less novel the experiences became, until it became locked in. Before a certain age, babies cannot remember that objects exist. Out of sight, out of mind. However, the information is being stored, and over time, that information is resparked and restored, and object permanence sets in. Suddenly, the baby remembers his toys exist and tries to find it. The automatic perceptual integrations that an animal has have to be retrieved from where it is stored and moved in some form to other regions to process that information. The brain cannot do an infinite amount of processing, nor can a single region of the brain do the whole brain's entire job. Therefore, there must be a manner in which consciousness, not the brain, decides which regions of the brain to synchronize together in order to get the desired outcome, which is especially clear for higher-level reasoning tasks. This means that consciousness must have a volitional nature so as to decide which circuits of the brain to wire together, and to decide if the results the brain automatically generated were useful or not. In order for consciousness to be capable of making a decision, it must be aware of the difference. And in fact then, consciousness is a form of awareness of two or more options. Not all consciousnesses are capable of fixing their situation when presented externally with only the bad option. But all consciousnesses will have some response to that awareness. Whether the decision is automatic or volitional, it is not random, nor is it deterministic, as it is possible that it decides not to respond. The higher the level of consciousness, the better it is at acting against those biasing factors that make determinism so appealing. Biasing factors, also known as physical gradients of nature, is what inanimate objects have no choice but to follow without the ability to do anything else. Consciousness, especially at the higher levels, has a physical component such that its existence depends on the existence of the brain, and the brain's existence depends on being able to come together through a complex process of physical gradients. But the result, consciousness, is not itself physical. Consciousness is mental, and mental things can pretend that physical things don't have the rules or properties that they do have. But a consciousness cannot pretend that nothingness exists. It can only replace all things with an empty room or a very dark empty room. Start of science. How can it be that consciousness can do all of this? How can it be that the brain can do all of this? How can it be that reality can do all of this? The answer to these questions must now be found using science, a methodology of acquiring facts and knowledge which is derived from this philosophical introduction. As a teaser for the science material that will follow this introduction, the answer will be found in what it means to be in a quantum superposition within the fabric of spacetime, and what it means for that quantum superposition to decohere within that fabric of spacetime. That some of the answer will lie with the idea that superpositions are the reason we have volition, as this mechanism allows the living being to make choices which are neither random nor determined. More importantly, this feature explains the neurological tests that suggest that the brain makes decisions before the mind can know it, using what is called a backwards time referral. This explains how a consciousness can make split-second decisions while the brain experiences sparks, which some neuroscientists believe proves that the brain is acting faster than consciousness can be aware. That consciousness is in aromatic rings and tubulin, which make up the microtubulas, which exist in a mixed polarity network within the pyramidal cells that are located at the integrating regions which can be found in the fifth layer of the cortex. These rings quantum entangle, which oscillate up, resonating with the neurons which construct the brain waves, which sync with the other regions of the brain which are required for the computations of the conceptual elements involved. And together, they objectively reduce to a classical state that acts as a moment of conscious awareness, and through millions of conscious moments integrated together, the tubulin construct a physical representation of the percepts or concepts through the physical remodeling of the microtubulin and the nerve cells that they inhabit in order to form the result, and that information is stored on the microtubulin through a kind of stamping of information onto the structure by a CAMK2's molecular electrostatic fingerprinting. This last part here was merely to show you that this triple integration of epistemology, mathematics, and neurology is based on a physical theory which combines relativity with quantum and quantum with biology, and that the philosophical implications are such that free will can be explained by physics with biology, and that your neurology, through both the microtubulins and the integrating regions of the brain, by their structure, is the reason why there is a crow-epistemology of percepts and concepts, that it is the neurology that sets the limits of the difference and agreements in percepts and concepts. This, then, is the introduction to everything. The subjects that we will now explore are physics. There are a countable number of things in the universe, and they are all related to each other in some measurable way. Calculus. The manner in which these physical things change is measurable. Chemistry. The countable number of things in the universe are composed of elements with a countable number of fundamental properties. Biology. A type of physical and chemical thing which has properties that other physical-chemical things do not have, and we can count and measure these differences. Neurology, a type of biological thing which gained additional properties of biology by integrating together biological properties to allow that biological thing to actively engage in energy retrieval. Epistemology, a special property of certain neurological things where the integrating centers repeat the process, but with their percepts and not just sensations. Psychology, a science measuring perceptions and conceptions. Given our current growth, I am certain that you can help us reach 1,000 subscribers by liking, commenting, and sharing this video, and of course, by subscribing to the channel. Thank you.